Have you ever asked someone to do something and they did exactly what you said, but not what you meant? Like, can you clean the kitchen? And they wipe the bench, but they leave the dishes, the floor, and the overflowing bin. Now, technically, they clean part of the kitchen, but that probably wasn't what you had in mind. And that's basically what happens in software development all the time. Before developers write code, someone has to describe what the software is supposed to do, and those descriptions are called requirements. A requirement might sound like the app should let users delete a record, which sounds simple enough, but if you wait for a second, what does delete actually mean? Does the record disappear forever, or is it hidden from the user but kept for audit purposes? Can anyone delete it, or only the owner? What happens if it's already linked to something important? And what if the user changes their mind halfway through the process? One short sentence, five different questions. And that's where requirements analysis comes in. You see, requirements analysis is a process of checking the instructions before the work begins. It asks a few simple things. Are these requirements clear? Are they complete? Are they consistent with each other? Can you actually test them? And do they describe what the software should do, not how to build it? The sharpest version of the question is this: could two people read this and reasonably build two different things? And if the answer is yes, you've probably found a requirement bug. And requirement bugs are really sneaky because they don't look like bugs at first. The words all seem fine, everybody nods, the project moves on. Then, weeks later, someone says, wait, that's not what I meant. By then, the design's done, the code's written, the tests are built, and changing direction is much more painful. And in fact, studies of this exact problem find that when instructions are ambiguous or incomplete, a large share of the code that gets generated is syntactically valid, but it does the wrong thing. It all compiles, it all runs, the tests pass, and yet it's still not what you asked for. Which brings us to the world of AI coding tools, because they raise the stakes. When you ask an AI coding agent to build something, your prompt becomes those requirements. If your prompt is vague, the AI doesn't stop and ask, it quietly fills in the missing details itself. It might make some reasonable guesses, but they're still guesses, made on your behalf and in some cases without you knowing. And AI writes code much faster than any human can review it, so the gap between what you meant and what you got built widens fast. So, instead of jumping straight from build me this feature to code, tools like Kiro encourage a much more deliberate and structured flow. First, they turn ideas into written requirements, then analyze them, then design the system, then break it into work tasks, and only then do they write the code. The clever part is in the analysis step. You see, Kiro scans your requirements for the classic problems we've just talked about: ambiguity, contradictions between rules, and missing scenarios that nobody thought about. Under the hood, it does something really cool. It translates your plain text requirements into formal logic and runs an automated reasoning engine over them to hunt for gaps and conflicts. It's the same family of techniques used to prove properties of safety critical systems. But here's the important part: it doesn't read your mind. When it finds something ambiguous, it doesn't try and guess, it asks you. For example, when you say remove the record, do you mean delete it forever or just hide it while keeping it for audit purposes? That's a much easier question to answer before the code exists than after it. And it points at what a very good requirement actually is. A good requirement isn't a wish, it's a clear statement of behavior. Not the system should authenticate users, but when a user submits valid login details, the system should return a valid session. The second version gives you inputs, conditions, and an expected result. You can actually test it. The first one, you can't even say what done looks like. So, here's a simple way to think about requirements analysis. It's proofreading the plan before you build the thing. It turns fuzzy ideas into clear instructions. It catches misunderstandings early while they're still cheap, and in the age of AI generated code, it makes sure that the machine builds exactly what you meant, not just what your prompt accidentally allowed it to build. Because as we all know, the cheapest bugs to fix are the ones that we catch before they become code.